Hello guys, let us discuss a very good functions problem. What do we have? We have a function f n to a. N is set of natural numbers here. A is an unknown set right now. G is n to b and they both are onto functions. So we can say range of f is a, range of g is b. F of n is step of n secant square theta and g of n is step of n cosecant square theta for some theta. If secant square theta is irrational, then which of the following options are correct? So we have to check. Basically, we have to find the range, and we have to see the relation between the range. Option A says A intersection B is 5. Option B, A union B is n. Option C, F is 1 1. Option D, G is not 1 1. Let us start with this 1 1 thing. So we know if secant square theta is irrational, it has to be more than 1. Secant square theta is basically greater than equal to 1. If it is irrational, it has to be more than 1. It can't be equal to 1. If you find f of n plus 1, it will become n plus 1 secant square theta step. You have to keep in mind secant square theta will act as a constant here. This value will be some fixed value, some fixed irrational value. N is our variable now. So f of n plus 1 will be step of n plus 1 secant square theta. When you break, you get n secant square theta plus secant square theta. Now, you know, secant square theta is more than 1. N secant square theta will be some irrational number because when you multiply n with some irrational number, it will be irrational number. Now, whatever it is, it will lie between some integers. Let us say this lie between, so this value is approximately say 3.4. The step of that would have been 3. But if you add a number which is more than 1, step will be more than 3. So what you will say is step of n secant square theta plus secant square theta step will be more than f of n, which is n secant square theta step. Because when you add a number which is more than 1, the step value will be the next one now. So this we can say for all of them. So f will always be an increasing function. So it has to be a 1 1 function. Because the next integer will always give you a value which will be at least 1 more than the previous one. Same thing we can say for g also. G will also be increasing, it will also be 1 1. So option D will be wrong. Now, let us check option A. Saying A intersection B is 5. So there is nothing common in A and B. Let us see how we can prove this thing. Uh, f of n, let us say, is k, and g of m is, let us say, equal to k. So we see that there is a number k which is in range of both the functions. F of n is k and g of m is k. So if f of n is k, we can say n secant square theta will be more than k less than k plus 1. Usually we take greater than equal to, but in this case we can say that the value cannot be equal to k because secant square theta is irrational. So n secant square theta will be some irrational number only. So n secant square theta between k and k plus 1, m cos secant square theta between k and k plus 1. Secant square theta you can write as 1 by cos square and multiply both sides. Similarly, this side, cosecant you can write as 1 by sine square, you multiply both the sides. So you get n is more than k cos square theta less than k plus 1 cos square theta. M is more than sine square theta less than k plus 1 as sine square theta. Now when you add these two equations, you get n plus m will be more than k less than k plus 1. We know n and m are natural numbers because the domain here. So n plus 1 has to be an integer. So it cannot lie between two consecutive integers, no? F of n was k, g of m was k, like this was k was a integer number because you see step value will always be some integral. So k and k plus 1 are both like they're consecutive integers. So n plus m, which is an integer, cannot lie between two consecutive integers. That means our assumption is wrong. So there can never be an element which is common in both of the range. So A intersection B has to be 5. So option A will be correct. Now the last option, A union B equal to n. This is saying every natural number will be either in A or in B. So there, when we take union, they will cover all the natural numbers. Let us see this one. Let us say there is a number k which is not in the range of f. A is the range of f. So there is a number k which is not in the range of f. That means there will be some value of n secant square theta which is less than k, and n plus 1 secant square theta will be more than k plus 1. So basically the function for a value will be less than k and next value will be more than k plus 1. So that the step will never be k, or you can say so that no value is between k and k plus 1. So there is no value between k and k plus 1. So some value is less than k and the next value is more than k plus 1. It kind of jumps. So some value is before k, next value is more than k plus 1. So nothing is between k and k plus 1. So k is not in the range of f. So now n secant square theta less than k, write secant as 1 over cos, you get n less than k cos square theta. And convert cos into sine, you get n less than k, 1 minus sine square theta. Then sine you convert into cosecant. So you get n cosecant square theta less than k times cosecant square theta minus 1. And if you combine the terms of cosecant square theta, you get k minus n cosecant square theta will be more than k then. K minus n cosecant square theta will be more than k. Now same thing here. N plus 1 secant square theta is more than k plus 1. So secant we can write as 1 over cos. So n plus 1 is more than k plus 1 cos square theta. And again we can write cos square theta as 1 minus sine square theta. Just write it here. So write cos as 1 minus sine and then sine as cosecant. So get n plus 1 cosecant square theta is more than k plus 1 cosecant square theta minus 1. And when you convert like take all the cosecant on one side, you get k plus 1 more than k minus n cosecant square theta. What do we say here now? K minus 1 cosecant square theta is more than k but less than k plus 1. That means if you find g of k minus 1, g of k minus 1 will be step of this thing. And you see this thing is more than k less than k plus 1, that means g of k minus 1 must be equal to k. So if there is a number which is this integral number, or you can say natural number, which is not in the range of a, it is a natural number which is not in the range of f, then that number must be in the range of g. So if k does not belong to a, it must belong to b. So overall, when you take the union, you will get set of natural numbers. This is a good problem, guys.